Okay, here we go. So a little bit about me before we actually go ahead in this session and discuss the topic that we want to discuss today. As you can see from this slide, I did my SCJP certification way back in December 2009. I am also SCWCD certified. I gave that certification last year, as you can see from there, and I have a training experience of over 3 years with Whizlabs. Okay. Now a bit about OCPJP6 exam. This exam is about 150 minutes duration. The total number of questions that you will need to solve in it is 60, and passing score is 61%. Okay, but it is subjected to change. So whenever you register, do check what is the passing score at that point of time. All right. Now the important thing regarding exam topics. So there is this great book called SCJP6 Study Guide by Kathy Sierra and Bert Bates. This is an excellent book for preparing for this exam, and this is the book that we also follow in our 4 days of training. So I will suggest anyone who is preparing for SCJP6 exam to just blindly go and get this book for sure. Based on this book, the syllabus of the exam can be actually divided into the 7 sections, which you can see here. And all of these sections are covered on a particular day of our training based on the logical flow of syllabus. So you can see this on this slide here. Okay. And that's pretty much it about the introduction part. So if you have any questions before we go into the technical session, let me know. Any questions anybody is having in general before we start the actual topic for today? Okay, I am not seeing any questions in the questions panel, so I will move ahead. Guys, please feel free to ask any questions you have at any point of time. This session will only be useful if you will try to keep it as interactive as possible. Okay. Anytime you have any questions during the session, please do let me know. Now, the topic that we are going to discuss today is one of the topic that is very, very useful for SCJP exam and for understanding the basics of Java as well. It's actually, I call something as heap stack diagram. It's a very useful approach which can actually make very complex problems very easy to solve, very systematic, and anyone who just understand a little bit about the basics can apply that technique and can solve very complex questions which would otherwise be difficult to solve. Okay, so before I discuss that technique, you will need to know about few things. Those things should be clear, only then you can actually successfully apply this approach. So let me begin. This approach is basically called heap stack diagram because it is related to how memory is managed in Java. So whenever your JVM starts, whatever memory it gets, it is actually divided into 2 sections. One is the heap section and another is stack section. Okay. Now this stack section is meant for storing local variables of your method. So whenever you execute any method in Java, a stack is created corresponding to it. So for example, in this stack section here, you will first of all create a stack for the main method. Okay. And then any method, any local variables that are created inside the main method will be created in this main stack here. Okay. But any objects that you create in Java ever, any object that you ever create in Java will always be created in an heap. Okay. So first of all, let me clarify the difference between object reference and objects, because I think that's basically confusion, that a source of confusion for most people. So in Java, you have only 2 kinds of variables. Only 2 kinds of variables are possible. The first type is primitive data types. So primitive data types are those variables whose value is whatever data you have supplied on the right hand side when initializing them. So for example, when you say int val equal to 90, okay, in this case this val is a primitive data type, and you can always say val is 90. Now whether this primitive data type is a local variable, an instance variable, or a static variable really doesn't matter, because anytime you represent this val in the diagram, you will say val colon 90. Now depending upon whether it is local variable or instance or static variable, its position will change in this diagram, but you will always write it as val colon 90. Right? So for example, if it is a local variable of the main method, you will say it as val 90, right? But if it is an instance variable of, let's say, a student object, you will say it something like this. At 1000x you have student object. Okay, sorry about the typos. And you will say that it has a val instance variable having value 90. So you can see anytime this val colon 90 is always there, its position is changing based upon what kind of variable it is. Great question from Ankit. What about static variables? So static variables are actually created in another section called class data, which is actually part of Heap only, okay, which actually stores the information regarding the class that has all the classes that have been loaded. So you have entry for each and every class that is loaded in Java. So for example, you have entry for student class if it is already loaded, right? And you will have a section called static variables here, okay, in which, let's say, if val is one of the static variables, then you can say val is 90. Right? So you can see, depending upon whether it is instance variable, static variable, or local variable, its position will change, but you will always represent it as val 90. Avinash, I'm not very sure what do you mean by perm area, but this class data section in the Heap is basically a section where your bytecodes of the class are kept. So you know that when you compile a .java file, what you get is bytecodes, right, in form of .class. That .class needs to be loaded in the JVM's memory, right? Otherwise, how will you be able to execute any method that is present in that class? So that class, that bytecodes are actually present here, obviously in a parsed format, so that you can easily invoke a method or anything like that, right? So all that information is kept here, and static variables are also kept here. This is because static variables belong to the class and they do not belong to any object, right? And you can see this val is 90 is actually in the student object here because it is an instance variable and belongs to an object, not to the class. Ankit's question is regarding static method invocation. So Ankit, there is actually nothing special about static method invocation. It's just that you call a static method on a class and not on an object. I'm not sure if that was your question or you wanted to ask something else regarding static methods. Okay, now second type of variables are object reference variables. Okay, please note very carefully, when I say object reference variables, these are not objects, these are just called reference variables. These are called reference variables because whenever you create a variable of type object reference, it has its value as the memory address. So for example, when you say student st equal to new student, okay, in this case you cannot say that st is having its value as this student object. That is incorrect. The correct thing to say is that there is a variable called st whose value is the address where the student object is stored. So for example, here in this case at 1000x location. Now again, depending upon what kind of object reference variable it is, whether it is local variable, static variable, or instance variable, you will put it in appropriate section, as we will see in a few questions that we are going to solve. But otherwise, it will always take this form. Variable name followed by address where it is pointing to, not the actual object which you have specified on the right hand side here. Okay, now keeping this very few basic things in mind, we can now actually go ahead and solve a few questions in which we can actually apply this approach. What we can actually do is just populate this diagram as we go along line by line in the code. And once you reach the line where you need to, let's say, determine what will be the output, you can just check the variable where that variable is residing in the diagram, and you can easily get the answer for that. Oh, Ankit's question is, data member of primitive types and simple primitive data variables are treated in almost same way. Ankit, I am not very sure what do you mean by data member of primitive types. Because simple primitive data variables are basically, there are actually nothing like simple or complex primitive data variables. There is only one type, which is primitive data types, and they are basically following. You have for integer values, you have byte, short, int, and long. For fractional values, you have float and double. You also have something called char, which is slightly related to integer data type, but not exactly the integer data type. And you have something called boolean. So these are the only primitive data types available in Java. Rest everything else will be a class and will obviously need an object reference variable to refer to an object of it. All right, so guys, let's begin with first question of today. I will give you a few minutes, a couple of minutes to be specific, to solve this question. It's not very complex. I hope that you will be able to solve it even without this diagram approach. But still, I will start with this, and in the end, when we are done with the duration time limit, I will solve this question using this diagram approach, and we will see how effectively we can do that. So here is the question for you. Question is very simple. You just need to tell me what will be the output if this code is run. And you can see three system.outs. One is here and two are here. So please remember, there will be three lines of output and you need to tell me all the three. So go ahead and you can type in your answers as soon as you are done in the questions panel itself. Oh, we have a couple of answers already. That's great. But still, we have about a minute left, so still some time is there. Just few more seconds left, guys. Alright, so guys, time is up. If anybody needs more time, please do let me know. I can still give you a few seconds, or otherwise I will start solving this. So anybody needs more time, or should I just go ahead? Okay, I didn't see anything in the questions panel, so I will go ahead. Okay, so guys, just give me a minute to just adjust the screens here. Okay, so I think both of the things should be visible clearly. Let me just remove this thing from here and let me start afresh. Okay, so what I am going to do is I am going to keep a heap and I am going to keep a stack here. So guys, by the way, are both the screens visible clearly side by side? Any issues in any of the screens? Both the notepad screen and the question. Okay, great. All right, so first thing that we are going to do is create a main stack for the main method. Okay, in the main method, you can see the first thing that we are doing is val equal to 200, right? So what I will do is I will create a local variable here called val. I will give it the value 200. Okay. After that, I'm saying student st1 equal to new student. So this is an object reference, so it will get its value as some address in the heap where the actual object is stored. So I will create an actual object in the heap, let's say at 1000x. You can see that student object will have an instance variable inside it called id, whose value will be always 100 whenever you initialize it, right? Because you can see we are initializing id with 100. So this is what you get after the first two lines of the main method. Next, you are saying st1.id equal to val. This is as simple as just checking where st1.id is. So you go to the location where st1 is pointing to 1000x. You check the id variable there, and you just change its value to whatever value val is having in the main stack, which is 200. This becomes 200. All right. After that, I am calling the update method. So I will create a separate stack now because we are calling a new method. Update stack. There is one input parameter that update method is expecting called st. So st will be created here. And you can see that in the main method, we are calling the update method by passing the parameter st1. So whatever value st1 is having, the same value will be used to initialize st in the update method, right? So st will get the value 1000x. Now when you say st.id equal to 300, you go to the location where st is pointing to, which is 1000x. You go there, change the value of id to 300. Okay. After that, you are saying st equal to new student, right? So here what you are trying to do is you are first of all creating a new student object because you are calling the student's constructor, and you are making the st reference variable point to that, right? So you will create a new variable, new object in the heap, right? And you will make st point to that. Please remember, I will not change st1's value now, right? I think sometimes people get confused that since st1 was used to initialize st, any change you do to st should reflect in st1. No, that is wrong. That cannot happen. A local variable of a method can only be modified in that particular method. That is why it is called local variable. So when I changed st here, st1 still remains the same in the main method. There is no way in which you can change st1 of the main method from the update method. Okay. After that, when you say st.id equal to 400, you just go to the location where st is pointing to, which is 2000x, change the value of id to 400. And you are done with the update method. As soon as a method is over, you can actually remove its stack because it is over. And now you come back to the main method, and I think it's quite easy to guess what will be the value of our first system.out, which is st1.id. You just need to go to the location where st1 is pointing to and print out the value of id there, which will be 300, right? You can see it easily in the diagram. It is pointing to 1000x where you have student object ID value is 300. As simple as that. We just drew the diagram and just followed it step by step without thinking too much. Then I move to the next line in the main method, student st2 equal to new student. I create a new local variable here called st2. I make it point to some new location called, let's say, 3000x. At 3000x, I have again a new student object whose ID value is 100 initially. After that, when you say st2.id equal to 500, you'll just go to the location where st2 is pointing to, which is 3000x, and change its value to 500. After that, you are calling switch students method. So what is going to happen, a stack is going to be created for it as well. Switch student stack. There are two parameters that this method is expecting, st1 and st2. Please note that I am passing these in the reversed order. Basically I'm passing it in the reverse order in the switch students method. So you can see here I am passing st2 comma st1 where I'm expecting st1 comma st2. So st1 in the switch student stack will get the value whatever st2's value is in the main stack, which is 3000x, and whatever value st1 is having in the main stack will be provided to st2 in the switch student stack. Let me know if this step is clear. Sunny's question is, I think it's a replay of the previous event. Sunny, if you're referring to the topic of the demo, then answer is no. Previously we had a demo on a different topic, not this one. Any confusions anybody is having in this step? Okay, then I will move ahead. Next step is simple. You go to the switch students method. First line is temp equal to st1.id. So you just go to the location where st1 is pointing to, which is 3000x. You go there, fetch the value of id, which is 500. So you put 500 here. Then you are saying st1.id equal to st2.id. So the value that needs to be updated is st1.id. So st1.id 3000x. This is the value that needs to be modified, and you need to put the new value here, which is st2.id, which is 1000x, and id is 300 there. So this will become 300 as well. Okay. After that, you are saying st2 equal to new student. So a new object will be created in the heap. Let's say at 4000x location. Student object ID value is 100, and st2 will be made to point to that, which is 4000x. After that, when you say st2.id equal to temp value is 500, you will put that 500 value at 4000x. So you will go to 4000x, you will check the value of id, change it to 500. And then after that, you will return from switch students. So switch student stack is removed because it is over. You come back to the main method, and now again it's quite easy to guess the output of last two lines. So I will left it for you guys to determine what will be the output. So can people quickly check the diagram and guess what will be the output now? Guys, the answer will be 300, 300. So you can see that 1000x you have ID value as 300, and 3000x also you have the ID value as 300. Okay, so answer will be 300, 300, 300. Okay, I can see quite a few questions, so let me answer them one by one. Ankit's question is where exactly stack memory is allocated and where exactly the heap memory is allocated. So Ankit, actually it is basically the division of memory whatever JVM has access to. So whenever it is started, it will have access to some memory, right? So whatever memory access it is having, it's just divided into two sections. One is heap, another is stack. and you can see what we are doing in stack section and what we are doing in the heap section. Ahmed's question is, when the heap is cleaned out, 2000x is still there? It's a good question, Ahmed. That is actually a topic of future webinar. That is actually called something called garbage collection. So all these objects in the heap, which you are seeing, in fact 4000 as well, 2000 and 4000x, which are not being used, they would be actually cleaned by a process called garbage collector. Okay, it is run time to time by the JVM to clean up the heap memory. Oh, Ankit's question is that related to XMX? Yes, Ankit. Actually, there is a flag called XMX, which you can actually use to configure how much heap memory you want and how much stack memory you want. For heap, the flag is XMX, so you can actually say something like Java, whenever you started, minus XMX, and after that you can supply some value like 512M, which is 512 megabytes. I think you probably use colon. I'm not very sure. That actually will need to be checked in the documentation. But the flag name is minus XMX, and for stack memory, I think there is a separate flag. But I am not sure about the name of it. But usually we don't use that, and we normally use this flag for setting heap memory only, not the stack memory. Thomas' question is, what are the best sources for reading material to understand Java memory model? Thomas, that would be actually explained very well even in the Kathy Serra book that I mentioned earlier, that SCJP6 study guide. But if you really want to go into deep details, then there is a book called Inside the JVM by Aventia. I'm not very sure of the author's name, but you can do a simple Google search of topic Inside JVM, and you will get that book in the first result. That book is definitely the best source if you really want to go into the deep of Java memory model. Ankit's default heap size, I'm not very sure how much it is. Normally, I would say it is 256 megabytes, but it can actually depend from system to system and what version of the JVM you are actually installing. But most of the time, the default heap size should be sufficient, and you should not be actually doing this. That is explicitly using this flag to increase the heap memory. If you are trying to do that, then you should have a strong reason that why you are actually trying to do that. Maybe if you are, let's say, processing huge images, or you're having some video processing code, which will load a lot of data in memory, then definitely you will need to do this. But yeah, first thing, whenever you use this flag, please do check on that you are doing it for the right reasons and not just because you are getting out of memory error and you just want to avoid that. If you are getting out of memory error, then using minus XMX is not the solution. First solution should be to check whether you have actually written the correct code or not. Because most of the times you will have something like memory leak, where you will have object references still pointing to some objects in the heap, even though that object you do not intend to use, and hence it will actually prevent garbage collector from using that. Okay, Ankit has actually given the name of the book as well. Oh, sorry, author of the book, Bill Venus. Thanks, Ankit, for that. Ankit, I think I already answered what happens when we load a large file. The file will be actually loaded in the JVM's memory, particularly in the heap. So for example, if you are creating some kind of image object and you have actually read the complete image in form of a byte array, right? That byte array would be created somewhere in the heap, right? So if you're really dealing with huge images, then obviously your heap size should be sufficient to actually accommodate that. All right, any further questions anybody is having till now? Okay, so I think we can move to the next question. Okay, so let's begin with this question. So again, few minutes for you to solve this question. Let me know what are your answers. No, this is one of the questions that is really difficult to solve if you try to solve it otherwise. But if you make the diagram, you will see that it's not that difficult to solve this one. Okay, so we have a couple of answers. Other people can also type in their answers. So just one more minute left, guys. Alright, so I think we can begin solving this question now. So let me start here by creating a heap and creating a stack as usual. In this stack, I will create a section for the method main stack. In the main method, you can see the first line is test t1 equal to new test, right? So what I'm doing is I'm creating a local variable here called t1, which will, let's say, point to some 1000x location in the heap. And at 1000x location, you will have a test object, which will have actually two instance variables inside it. One is val, which you can easily see that will be initialized with 1, right? Because we are calling it to construct here, this one. And there will be another instance variable called t, which will be null, right? Because we are not initializing it. Then I'm saying test t2 equal to new test 1. So I clicked another local variable here called t2, which is let's say 0.2x. And what I do is I create another object. Its value will be 2 this time. These check arguments, and the value of t will be whatever value t1 is having in the main stack, right? Because we passed t1 as the second parameter, and we called this constructor. So it will get the value 1000x. Then we are saying test t3 equal to new test t3 comma t1. So I create another local variable here called t3, make it point to 3000x. At 3000x, I create another test object. Value is 3, and I have t. Again, it will point to 1000x because please check the parameter. I'm still passing t1 in the second constructor. So still it will be initialized with 1000x. And after that, the last object, which is referred by t4. So I will have t4 here. Let's say it is pointing to 4000x. At 4000x, I will have another test object. Val will be 4 this time, and t value will be, this time what will be the value of t? $2000x, right? Because we are actually saying 4, t2. T2's value is 2000x, so this is what goes there. Alright, after that, t2.t equal to t3. This is simple. You just go to the location t2, which is 2000x, and you need to modify this t, and the new value that you need to put here is t3's value, which is 3000x. So you just update this, put 3000x here. Right, you put 3000x there. After that, you are saying t3.t equal to t4. So you go to the location where t3 is pointing to, which is 3000x, and this t is the one that you need to modify. And the new value that you want to put here is t4's. T4's value is 4000x, so this becomes 4000x. Then you are saying t1.t equal to t2.t. So let's evaluate t2.t first, the right hand side. Right hand side is t2.t, which is 2000x, and the value of t there, which is 3000x. So we need to put 3000x value somewhere, but where exactly we need to put it? We need to put it as t1.t. T1.t is 1000x here, and this particular t here. So what we need to put here is 3000x. Right, this is what we evaluated. Finally, we have t2.t equal to t4.t. So let's evaluate t4.t. T4.t is, you go to the 4000 location where t4 is pointing to, and you get the value of t there, which is 2000x. So this 2000 is something that we need to place at a particular location, which is t2.t. T2.t is, you go to the location t2, which is 2000x, and this is the t that you need to modify, and you need to put the new value here, which is 2000x. Okay, and that is it. And that is it. You are done with all these updates. Now all you need to do is just follow these reference variables and get the output of these last 4 system.out. I will do the first one for you. t1.t.val. You just need to go to the location where t1 is pointing to, which is 1000x. Go to where t is pointing there, which is 3000x. You go there, and the value of val there, which is 3. So this will come as the first output, 3. If you do the similar exercise for the last 3, you will get the answer as 3, 2, 4, 2. Any questions anybody is having here? Okay. Guys, maybe very quickly what we can do is we can very quickly actually guess the output for this question here as well. Let me check if it is in the correct format that I actually wanted to see. Yeah, I think never mind, we can actually solve this question. So time is not much there, so I will not be able to give you much time rather than some time to just look over this code. Okay, so meanwhile I'm just clearing up this notepad screen. You can just have a look at this code again. The same thing is what will be the output. of this code. Okay, this time we will have arrays, so it will be interesting, and we have static variables as well. Okay, so two new things will be there in the diagram now. Alright guys, I think I will need to actually solve this now, otherwise we will run out of time. So this time we have static variable, as you can see here, so I will actually create that class data section. Okay, and you can see that whenever this alpha class is loaded, you will have an entry for it. Ankit, we will see that very shortly. Okay, you will have the alpha dot class here, as I said, in the class data section, and you will have a section for static variables. And in this static variable section here, you will have, there are two static variables you can see, sval and b, right? So both of these will be created here. So you will first of all create the static variable sval, which will have the value 200, and you will also create another static variable called b, which will point to some location in the heap, let's say at 1000x, where you will have a beta object. Okay, beta class doesn't have any instance variable or static variable, so it will be just a simple object like this. After that, when you start with the main method, the first thing is alpha am1 equal to new alpha 4, right? So you, in the main stack, you create a local variable am1, which will, let's say, point to 2000x in the heap. At 2000x, you will have what? An alpha object. Okay, alpha object, you can see, is having an instance variable inside it called val, which we are initializing. So val instance variable will be there and it will be initialized with the value 4. Then you are creating another alpha object and referring it through am2. So you will just do that. Val will be there and the val value will be 1. You can see from the constructor that we are calling. Right. After that, what you're doing is you're calling a method called fill. So a fill stack will be created. In the fill method, there are two local variables, a1 and a2. a1's value will be 2000x. a2's value will be 3000x. What you are doing is you are saying a1.val equal to 2. So you go to the location where a1 is pointing to 2000x. You go there and change the value from 4 to 2. Then you are creating an array here, right? So how will the array be represented? Again, array reference variables are just like any other object reference variables. They will point to some location in the heap, right? So for example, this array reference variable fa will point to some location in the heap where you will have an array object, right? Which will have placeholder for two locations, because you can see we are creating the array with size 2. This is an array of object references, so it will internally store the object references in the individual indexes. We are providing a2 at the 0th index and a1 at the 1st index, right? So what we will have in this array is following. Right, you can see 3000x at 0th location and 2000x at the first location, because a2 is having value 3000x, a1 is having 2000x. After that, you just return this array. So FA's address is returned and it is cached in the main method in an array reference variable called AR. So AR gets the value 4000x, right? the fill method is over, so I can remove its stack. After that, you are saying AR0 equal to M1. You go to the location where AR is pointing to, which is 4000x, and you just change the value at the 0th index to whatever value AM1 is having, which is 2000x. And that is it. You are done. Now, I think you guys can easily guess the output of the last two system.outs. What will it be? Just need to go to the location where AR is pointing to, go to its 0th and 1st index and guess the value of val there. Absolutely, as people have written, answer will be 2, because you can see at AR0, 4000x, you have this 2000x, and at 2000x, you have the val value 2. In fact, both the 0th index and the 1st index are having value 2000x, right? And where the val value is 2. So answer will be 2 from here. Okay. So guys, that was about it from my side. I think I might have actually taken more time than I was supposed to take. So Raj, I think you can take over. Meanwhile, I will handle any questions people are actually having here.